Today we're going to do section 9.1, sequences. Now what is a sequence? A sequence is the way it sounds, okay? On page 886, there's a sequence. Here's some numbers, is 2, 4, 8, 16, 32. That, and it goes on. This is a sequence. Now each, that is, you can see that each time the number doubles itself, okay? And each number is called a term, which is fine. And as a whole, this sequence has this particular pattern, as you see a little bit later on the page, where it says, see, 2 is actually 2 to the power 1, 4 is 2 to the power 2, and 32 is 2 to the power 5. Eventually, each term, okay, this is the first and the second and third, this is the nth term. And so and that is how your sequence can be written. And therefore, the formula for this sequence, you can write it as an equals to 2 to the power n. That an is the nth term. That is, if a3 will be the third term, which is 8, okay? And then say a5 is 2 to the fifth, which is 32. That's the fifth term, and so on. So eventually, if you go to A31, that's 2 billion something. Okay, that is, so that is what a sequence is. So let's turn the page, and you can plot the sequence on the graph. Then this is page 887. If you were to plot it on the graph on the following page, then you can have something like this. That is, here's your graph for the sequence. First number on the sequence 1 is 2. Okay, the second number is 4, and the third number is 8, and so on. So you can graph that thing that looks like that. And sometimes we do graph sequences. Now the difference between an infinite and finite sequence is just that the finite sequence stops at some point, whereas the infinite sequence doesn't. It just goes on. For example, you might say the infinite sequence of 2 to the power n for any kind of n. Okay, n goes from 1 to infinity. That is, so you have this infinite list of stuff, and then they're all lined up as a sequence. Now so let's look at example 1 on page 888. And what are we doing here? We're looking at the sequence that called an equals to minus 3n plus 8. And so the example 1, we what are we doing here? We need to figure out, just need to write them out. The sequence is given as minus 3n plus 8. And how do you write it out? You just plug in the numbers. The first number is, the a1 is when n equal to 1, okay? When n equal to 1, that becomes 5. When n equal to 2, that it becomes 2, and so on. You can just plug it in yourself very quickly. So please do example 1 yourself, okay? And then we'll look at the next page. On the next page, we have example 2, where we have something called an alternating sequence, and we'll see what that means in a second. But the an is minus 1 to the power n squared, n plus 1. So you just plug in n for each term. N equals 1, 2, 3, 4, 5. And when you do that, and not mess up, okay, because there's a minus 1 here. Minus 1 to the 1 power is negative. Minus 1 to the second power is positive, and you have to remember that. But anyway, so if you keep all that clear, eventually, then you'll be able to come up these 5 numbers, okay? So, and those are the first 5 terms of the sequence an equals to minus 1, etc. And you notice that because it has a minus 1 to the power n in there, it's positive when n is even and negative when n is not. So as a result, it goes positive, negative, and stuff. So as a result of that, we call them alternating. That means they're alternating between being positive and being negative. So please do example 2 yourself. And it can also be plotted on a graph like this, okay, just the points. The x-coordinate is whether they're the first, second, third, fourth, or fifth. And then the second coordinate is the value of the sequence term. So then you can see there's the dots. In this case, the dots are going all over the place, okay? Because they're positive now and then negative next and positive again. So they're doing this jumping around bit. So that's example 2. So next, let's look at example 3. There is example 3 is a sequence again, but this sequence is defined with even more words. That is, let's look at example 3. This is on page, in the following page, 890. Where it says, the an says, what is an again? Well, an is equal to n squared if n is not divisible by 3. And it equals to n divided by 3 if n is divisible by 3. Okay, so you just follow that rule, okay? And a1, 1 is not divisible by 3, so it's 1 squared. 2 is not divisible by 3, so it's 2 squared. And 3 is divisible by 3, so a3 equals to 1, and so on. So please do that yourself. That's example 3. And next, let's look at example 4 on the following page. Next, let's look at example 4 on page 891. Now this example is more difficult. I mean, slightly more difficult. So then we have to consider them more carefully. What happens is we have a series already, and we're supposed to come up with a formula that fit this stuff. Okay, so that so we have to figure something out. Now let's look at part A, where we have a bunch of fractions. Okay, we'll look at them one at a time. First, they go negative, positive, etc. So they have a -1 situation going here. And how does the -1 work? The first term, as you notice, is negative, and the second term is positive. So we'll just write an n here. Okay, so and when n is 1, the term will be negative, and when n is 2, the term will be positive. If the other way is true, we can change it to n plus 1. That will change the dynamics. But right now, we just need an n, because we just need some kind of n here such that it's positive when it is even and negative when n is odd. So we got the sign taken care of right there. The second thing is the term on top. It goes at 2, 3, 4, 5, 6. Okay, which means that the first term is 2, and the second term is 3, and the third term is 4. So every term at the nth term is always n plus 1. It's 1 more than what it was before. So we'll write down the n plus 1. And then what is on the bottom? On the bottom, start at 11. Okay, and then go up by 2, right? So when it's 1 is 11, when it's 2 is 13, and when it's 3 is 15. So generally speaking, when it's, let's see, how will we come up with some n? So 1 will be, say n will start with 11. When n is 1, then, let's see, when n is 1, let's do this, okay? When n equals to 1, the number is the sequence term. We'll call it an equals to 11, okay? N equals to 2, then an equals to 13. So how will we go about getting a formula for this? We can do among other things, we can do, the formula right here, okay? That is, let me think how I want to explain this. All right, now I think I'll just go ahead and explain this like the standard way. That is, this is the same as a point on the graph, okay? Where this goes the direction of n, and this is the direction of an. That is, when n is 1, an equals to 11, okay? And when n is 2, an equals to 13. So you have 2 points, and what we need to know is what is the formula of the straight line across it. So we do this equation right here, which is y minus y1 divided by x minus x1 equals to y2 minus y1 divided by x2 minus x1. Now in this case, the x's are n, okay, and the y's are the an's. So then if you follow that, then that should come out with, that would make better sense. In other words, to rewrite this in this form, we will have an minus, which is y1, pick one, doesn't matter. We'll pick this one as y1, okay, so 11 divided by x is n, okay, and when the x1 will be 1, n minus 1 equals to y2, this minus that, y2 minus y1, that is equal to 2 over x2 minus x1 is 1. That is, so when you rewrite this formula out, that will be, then we have cross multiplying, okay? So then it have 2n minus 2 equals to an minus 11. And then you simplify this thing a little bit, it will be equal to n minus, let's see, did I get this wrong? Yeah, I made a mistake right here. It's 2 times n minus 1, right? So that should be n minus 1. I don't know why I have a 2 here. That's why it didn't make any sense. Okay, n minus 1. And then equals to that. And then we have, so we have then n equals, so 2n equals to an minus 11 and then plus 2, right? The 2 minus 2 over here becomes plus 2. So then I still can't get this to come out. Why? Actually, I'm fine. Anyway, so this is going to be, so an is equal to 2n plus 9. And that is the formula, okay? Now, the book wants you to just guess it, which in a simple situation like this, you can guess this very quickly. But if the numbers are bigger or more complicated or harder to think, then you wouldn't be able to, why make this stuff up on your head? This is the standard formula. Even if an is some weird number and stuff, it makes no difference. So this is this will be x1, okay? If x1, and then this is x2. And this is y1 and y2. If you follow this formula, this is a linear relationship. So that this is the old formula that it should be memorized. Okay, this is used all the time, even here. So anyway, so an equals to 2n plus 9 satisfies this equation down here, where we have the n equal 1 is 11, n equal 2 is 13, and so on. So this is that number right here. Is that equation right there is 2n plus 9. And you can test it. If n is 1, and that gives you 11, okay? When n is 2, then it gives you 13, and you can see that it goes up exactly like it's supposed to. So as a result, the answer is, for this sequence, is that an equals to this stuff right here. All right, so that is, that's that. And that's just part A. Now, part B, we have something that's similar, but let's do it anyway. Okay. The part B, we have a lot of minuses. Everybody's a minus, so we can just write down the minus sign. That was part A. Now we're doing part B. So we have a bunch of negative signs, so that stays the same. Okay. And then is 2 on top of everybody. So minus 1 times 2, that changes nothing. Okay. What's on the bottom? First is 25, then which is 5 squared. So the first term is 5 squared. The second term is 5 to the power 3. Okay, 5 to the power 3 is 125. 5 to the power 4 is 625. So it's basically 5 to the power n plus 1. That is, the first one is squared, the second one is cubed, the third one's fourth power. So each one is one more, okay, than its location. So that should be the answer. And let's see, what are they? Yep. So then what happens to the negative sign? It's right there. Okay, minus 2 over 5n plus 1 on the next page is the answer to part B. All right, so continuing, let's look at C. C is not that different, okay? We have a bunch of e's there. E is a set number, but we don't care what it is right now because we just need to write down what is the rule here. E is 2.718, I want to say, but we don't care, okay? So right now, so the first number is e to the power 4. The second number is e to the power 5. So basically, the sequence goes like this, 4 plus n. Right? Because the first number, 3 plus n is one less. So the first number, it would be 4 if it's 3 plus n. So because we start counting at 1, so the first number will be 1 plus 3 is 4, second number 2 plus 3 is 5, and so on. So that will be the answer for this sequence. All right, and yep, and that is the answer to it. Okay. So next, let's look at page 8, bottom of page 892, where we have something called a recursive sequence. What does that mean? It means each sequence number value is determined by the term before. You start with the first one, of course. So we have a definition that says A1 is 3, that's fine. It says, and then following, everything is the previous one multiplied by 2 minus 1. Okay, I'll say that again. Each term after the first one is equal to the one right before it times 2 minus 1. So knowing that, then you can work the sequence out one at a time. The first one, of course, is 3, is given to us. The second one is the first one times 2 minus 1. 3 times 2 minus 1 is 5. So the second one is 5. The third one is 5 times 2 minus 1, and that gives us 9. The fourth one is 9 times 2 minus 1, which gives us 17. And you keep going like this. And as you notice, if you mess up one of them, then everything behind after you is all screwed up. Okay? And so that's the problem with, well, that's my problem with recursive sequence. Is I have a tendency to make mistakes. And if I make one mistake, then, you know, the whole line afterwards is shot. But otherwise, is whereas the other sequence calculations, they give the formula for each term, which means even if you mess up one of the terms, it doesn't necessarily mean you mess up all the rest of them, right? Because they're not directly related. You just follow a set formula that calculate each term. Whereas this one, the recursive formula means each thing depends on what's before. So in order to know, say, the fifth term, you have to calculate all previous 4 terms first. And if you have to figure out what the 1000th term is, you have to figure out all 999, right, before you can get to the 1000th. Whereas the one that's defined with a regular formula, if you need to know what the 1000th term is, you just crank it out. You don't care what the other 999 was. So that is that. So as a result, the recursive formula is not as direct. So most of the time, we try to write formulas that's not recursive if possible. But that is not always possible, of course. That anyway, let's see. So next, let's look at example 5 on page 892, where we have, you just have to write out terms of a sequence, but that is defined by a recursive formula. So you just do, basically, you just do as you're told. Okay, where did it go? I lost it. So we have a bunch of stuff. A1 is as defined here. Example 5 is 9. And then AN, the next one is always the previous one times 3 minus 20. So you can do that easily enough. Okay, so please do that yourself. And that gives you a feeling of how recursive stuff works. And then the recursive sequence, as other sequences, can also be plotted as points on the graph. Sometimes that's useful. And so next, let's look at example 6. Now, example 6 is is a recursive formula, but it's not defined with the previous one. It's defined by the previous 2 terms, like this. Okay, we have, say, A1 equals to some number, and then A2 is some other number, and then after that is depend on the first 2 terms. It's 3 times the previous one, and then 4 times the one before the previous one. And you keep moving along that way, so that the third term then it depends on term 1 and term 2. The fourth term then depends on term 3 and term 2, and the fifth term depends on term 4 and term 3, and so on. So each guy depends on not just the guy before him, but 2 guys, both guys before him. okay? And then you do some calculation and crank it out. So please do example 6 yourself as part of your homework. And then and let's look at the following page, page 895. Now, and on the page 895, we learned something that is probably new to you. It's called the factorial. The factorial is written as an exclamation mark, such as 5 exclamation mark. That means 5 factorial, and 4 factorial, and so on. The factorial is only defined for positive numbers. And what that means is anything that you calculate the factorial, it will take itself and then multiply by all the numbers before it until you get down to 1. For example, the factorial of 4, as shown on this page 895, is 4 times 3 times 2 times 1. Okay? And that happens to be 24. 5 factorial equals 5 times 4 times 3 times 2 times 1, which happens to be 120, and so on. Now, so generally speaking, the factorial is a bunch of numbers that you multiply one at a time, not missing any, go all the way from itself and down 1, all the way down to 1. So because of this definition, then, we can think of, for example, 5 factorial is the same as 5 times 4 factorial, okay? It makes sense if you think about it. And then there are a couple more points, is that 1 factorial, what's 1 factorial? It's just 1. So then 1 factorial is just 1. What's 0 factorial? 0 factorial doesn't make any sense, but by tradition, okay, and we define 0 factorial as 1. It's convenient to do it that way. Now, so respect the tradition. And so 0 factorial, you have to memorize this fact, is that 0 factorial equals to 1. And of course, if you don't remember it, if you punch it into the calculator, it'll tell you the same thing, because the calculator is also programmed to say 0 factorial is 1, period. And don't think too hard about that. And so let's look at example 7, where we have a sequence that has factorial in it. Well, that changes nothing, okay? You just plug it in and crank it out. As in this example 7 on the following page, we have, let's see, let me make it a little bigger. Okay, we have some kind of an is defined that way, so we just crank it in and calculate the whole thing. The factorial can be done on the calculator, okay? And there is a symbol on a button on there that you can punch that will give you the value of the factorial. So the first one, n equal to 1, then it becomes 5 divided by 3 factorial, and you figure out what that is, okay? n equal to 2, the same way, that becomes 10 divided by 4 factorial, and you figure out what that is, and so on. So please do this example 7 as part of your homework. And then we have come to the end of this section. I will finish this section in the next video.